acid in it. How many of y'all like fruit? Or be eating fruit juice?
What?
Drinking fruit juice, I guess.
What about
Hey, what's in lemons? What makes them sour? Citric acid. Things like chocolate, cocoa, caffeine also have acids in them or can be acidic. How many of y'all have taken a shower within the last 24 hours? Or some sort of bathe material? You interacted with soap. Soap is a base. Have any of y'all's mom or dads or parents or grandparents, aunts, uncles, whatever, ever threatened to wash your mouth out with soap?
Yes. No. My dad has been washing his mouth.
What did that soap taste like? It tasted like bad. It tasted bitter. Gross.
Wait, they actually did it to you guys? Wow, that's my dad. That's not a shock.
Acids. Acids have a pleasant, sour taste to it. It's bearable. Whereas bases are extremely bitter to the point where they make you throw up if you eat them. It tastes bad. I just compared bases to soap. Is soap, how would you characterize soap?
Clean.
Sudsy. What else? What other S words?
Soapy. Foamy.
Soapy. S words, people. S words.
Slippery.
Slippery! It's on the board.
Skinny.
Bases are very, very slippery. But when we look at acids, when you eat salt and vinegar chips, what sticks to your fingers? All
The vinegar.
the salt and
It
oil,
makes it
the
so
vinegar.
it'll make your hands sticky.
When you eat fruits like oranges, when you peel your orange, what happens to your fingers? They get sticky from the orange juice.
Miss One wanna die.
So acids. What?
She's allergic to oranges. So like you'll like eat an orange, she's like, whoa, whoa, whoa,
Get
whoa.
out of my classroom! Get out!
She's very allergic to
She's like,
oranges.
Carolyn, go sit down in the hallway. Go sit down in the hallway.
Like they can't
Like,
be
not in the hallway.
around her.
Anyways.
Out of the school.
Acids are very, very sticky. Where bases, very opposite, very, very slippery. They roll right off. Something else about acids and bases that they have in common is actually their level of danger. Normally, if I were to say, in this hand, I have a jar full of acid, hydrochloric acid, sulfuric acid, whatever. But in this hand, I have some base, sodium hydroxide, for example. Which one would you think is more dangerous off the bat? The acids. It's built in your nature from things like TV shows and movies that acids are more dangerous than bases. That's not true. As a matter of fact, they're both very dangerous. And the reason for that is because they're both considered corrosive. Corrosive materials eat at other things. That's why last week when we used hydrochloric acid in lab, I made y'all wear gloves and suggested long pants, long shirts, and goggles, of course. Next week, you're gonna do a lab with sodium hydroxide and hydrochloric acid. I'm gonna recommend the same things because their whole job is to protect you from both of those compounds getting on your skin
This body's a temple.
before they eat away at your skin.
Freaking choreograph, bro.
Anyways. Other things that can contain bases of many household cleaning items, things like bleach, toilet cleaner, Drano.
What?
What is
It's very clear you guys have
Clears
never
out the drainage.
you guys have never cleaned a bathroom before.
Yes, I have, but I've never used that.
How have you never
I've
used
never done
Drano?
that.
You pour it in the
You pour it
sink.
down your drain to make sure your drain doesn't get
and
clogged
it
up.
comes up and then it comes to the hole.
No, that's just
No, I just
foam.
take my drain out and then clean it.
No, like there's this like
You
candy
can't-
like
I don't
stick
know
in
what
the
you're talking about.
in the drain.
All right, that is this argument is not the point of the point. Not the point of the point. That makes sense.
What's the point of the point? You should be an English teacher.
Oh, golly, me and Miss Scales can trade places for a week.
Well, I think you should.
I think I would absolutely
we would
hate
fail
my
all our
life. I would.
tests.
I could never teach English.
when she gives us a quiz and you had
Well,
no
she also
idea what
teaches
you're talking
speech.
about.
I could never teach speech either. I love public speaking. I'm very good at it, but I hate it.
You
No, you don't have one for speech.
Keep up
It's
all
work.
of Miss Smith.
She talked for the
has
first
three
time
separate classes. She
this
has
week, and she's
journalism,
not going to talk the rest of the week.
I love
English
Yeah, she
honors,
taught
and
us.
Yeah, I would simply die. All right. The next point we have are called indicators. Now, you guys haven't used an indicator. You're going to use one next week. Actually, Grace has used an indicator.
Why is it special?
Is that great?
Because she did it in her study hall when she was helping me get rid of some old acids. Indicators allow us to determine visually, very quickly, the pH of a solution. Now, I'm not going to spend a whole lot of time talking about the pH scale today because we have 2 whole days dedicated to the pH scale next week on Monday and Tuesday. Have y'all talked about the pH scale before?
Yes,
Yeah.
we have.
We did a whole lab about it in bio.
Oh,
It was like a whole unit. Yeah,
Mhm.
it was quite fun.
well, you're going to love how to calculate pH now.
No.
What?
Oh,
Can
yeah.
we just use the strips and call it a day?
We're going to use things like logarithms and exponents.
Oh, that's what we're learning about algebra.
Alright, bro.
I don't even know.
I'm basically Isaac Newton.
So, are you?
Just let the apple fall on my head and I'm basically him. I am
He can't
Timothy.
be, he can't be
Timmy
like-
Neutron,
he
Timothy
can't
Turner.
be the highest for you because no way he gets an apple and then he's like,
He's gonna drop an apple. It's about to
The two have a different indicator color. Most of the time, the most common indicator that we are going to use this year is just a universal indicator. And it's very clear to tell what the pH of a solution is based off of the color of the indicator. Whereas there are other indicators that you will use in Chem 2, such as phenolphthalein, that only turn one color, a pretty little pink.
Pretty little pig.
For our purposes with indicators such as universal indicator or even pH paper, you'll also use that next week. You can determine the pH of a solution, whether it's acidic or basic, based off of the color that that indicator turns.
Like
Typically, acids are very red if it's a strong, concentrated acid. Typically, bases are bluish purple. Okay, you'll see that next week. Both of them are electrolytes. We did electrolytes last unit, meaning they will both dissociate in water. But yesterday, we said that only the strong acids and the strong bases, will completely dissociate. Those are known as the strong electrolytes. Okay. Then we have water.
maybe later.
Water. Water bottle. And a water bottle. Water. Water is special. Water, the universal solvent, the king of all liquids. It's great. But water can be considered acidic or basic, even though it's just H2O.
Refreshing.
Very. Hopefully by the end of this lesson, I will be able to convince you as to why water can act as both an acid and a base.
Hey, yo, we believe you. You know that.
I'm gonna prove it.
We got you.
All right. Can I click on? I'm taking that as a yes. Okay. All right. With acids and bases, we can characterize them into 2 different categories. What we call Arrhenius, or Arrhenius. And then we have Bronsted-Lowrys. You guys are going to love Arrhenius more because it's a lot easier. Bronsted-Lowrys are a little more fun. Arrhenius acids and bases look at the increase of a concentration. Remind me, what does concentration mean from last unit?
More acid.
No.
More substance.
Starts with an M. Molarity. Molarity, strength. If something is more concentrated, remember there's more solutes. Something is less concentrated, less solute. We are going to look at Arrhenius for a little bit, which is all about increasing the concentration of one of 2 things. The first is hydronium. Hydronium's on your polyatomic ion list, even though it's not really a polyatomic. Hydronium is just a water molecule that has sucked in an extra hydrogen. For our intents and purposes in the future, we're going to see how similar hydronium is with a hydrogen atom, a proton. But for today, we're just going to refer to it as hydronium. Whereas Arrhenius bases, on the other hand, are all about the formation of hydroxides. That is a polyatomic that we've used before. It is also on your polyatomic ion list. Hydroxides, signal base. Base, 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 base. Now there's a couple exceptions to that rule. And yesterday I told you that there were some exceptions to the base rule where there's one base that we're going to talk about in this class that doesn't have an OH in it. And I also said there's one acid, technically two, that don't start with hydrogen. We're also going to talk about him today. Hemothy, hemineutron, hemiturner.
Door.
What?
On your right.
There is a door on my right. There's also one on my left.
Get out.
Did you know bloodborne, you can get really sick from somebody pooping in the pool?
Thanks, Claire.
Like, cause like the
Hey, so
no, like the
peace and
acids
love.
mix. No, like it's relates. Cause you know.
Sometimes we have inside thoughts and those need to stay on the inside.
No, but do you see what I'm saying though? Like the chemicals like react.
I don't think I was going
Bro,
to see
I
what
love
Like
you're
the-
saying.
I love when Claire shares her
The
love
chlorine and the feces, like they'll react, and you can get really sick from it.
facts. Claire, that's so interesting.
We can do some research over that. Maybe you can do a research project for that. It's in the chemical closet right now.
That's why you have to always exit the pool.
Hey, can I click on?
Yes, sir.
Hey, I need you to draw some things.
No thanks.
I want you to draw two beakers.
Can we draw a rooster?
Womp womp. Draw two beakers.
Hello?
Hello? I wish I was a little bit taller. I wish I was a baller. I wish I had.
Fill the beakers with water.
What up?
I guess picking a blue pen was the right move today. Wait, what are you doing Wednesday after 7? I think I have soccer.
AD, do you have two beakers, Ron?
Yeah, I do.
Fill them up with one fill with nitric acid. Hey, what's the formula for nitric acid?
Oh.
What's nitric acid?
H2O.
It's a nitrate. Very good. So it's HNO3. And that's going to go in one beaker. Then we're going to put a compound called sodium hydroxide, which was one of the strong bases we talked about yesterday. And we're going to put that in the other beaker.
Why did you touch me?
Hey, acids. Let's start with nitric acid. Is that an electrolyte? Will it dissociate in water? We learned that last unit.
Well, I don't know.
We learned that last unit.
Yes, it will dissociate in water.
It will. It dissociates into its two ions, H plus
Stop touching me.
and NO3 minus. Hey, go back. Well, it's still on the board, actually. What does it say Arrhenius acids increase the concentration of? Or what do they form?
Hydronium ions.
Hydronium. Hey, based off of what's in my beaker right now, what can I combine in order to get hydronium? Looking at what's in my beaker, what can combine to get hydronium?
The hydrogens and oxygen.
So hydrogen and the,
Oxygen.
Hydrogen.
huh?
The H2O.
The water. I can combine the H plus and the water to form hydronium.
Dude.
Hey, let's look at where that plus comes from. You see how water's neutral? How there's no charge on it? But it's taking in an extra positive guy. It's taking in an extra proton. That's where that plus comes from. This is the basic Arrhenius acid.
I don't want to get your back. Nothing, I was meant to conversation. I just want to forget.
Tastes like coconut.
Look at the bases. Do bases dissociate in water?
Probably not. Yeah.
They do. Remember, electrolytes. We did this last unit. Bases will dissociate in water. So this guy is going to break up into sodiums and hydroxides. Hey, what does it say Arrhenius bases form?
Hydroxide ions.
Hey, do I need to do a reaction?
No, they're not.
Look, there's already a hydroxide in there. The hydroxide's already here.
Oops.
This is the Arrhenius base.
Oh, it
Wait,
has.
so is it just that in like that little OH is the Arrhenius base? It's not the whole thing.
I mean, I say that, it's like the whole system
Okay.
is the formation
But
of
what
Arrhenius
makes it
base.
an Arrhenius base is the OH.
But what makes it is the OH. So sodium hydroxide is an Arrhenius base because it forms hydroxide ions. Nitric acid is an Arrhenius acid because when it's dissolved in water, it produces hydronium.
What does Arrhenius mean?
It's an old dead guy. He's the guy that came up with this.
Is he your grandpa?
Great uncle.
I'm glad to see
Knew there was
some.
I knew there was chemistry in your blood, bro.
Are you ready?
There has been, bro. It's related to everybody.
Ready for what?
Remember, like the first lesson you taught us, it was like this great.
If somebody poops in the pool,
Okay, bro.
you can get E. coli.
Dude, you hit my camera, bro. It's all crooked.
But the last thing I want to do
You can get E. coli and
All right.
norovirus.
Arrhenius, simple enough. If it's an Arrhenius base, it forms hydroxide when it dissolves in water. If it's an Arrhenius acid, when it dissolves, the H plus will react with the water to form hydronium. Which one of these is longer? The acids. The acids has this extra step. This extra step in chemistry is very, very famous. It's called the acid workup step. I'm not ever going to test you on that, but for those of you that plan on going into medical fields or further chemistry, when you take organic chemistry in college, you're going to learn all about this, and you're going to hate it.
Yay.
Moving on.
I'm not doing that.
The second type of acid that we have is called the Bronsted-Lowry acids and bases. Write that stuff down,
Oh my
please.
heavens.
What's the story of your page? Oops. Your finger's wet.
Being negative Nancy over here.
Come on, Claire, pass them out.
Sorry. Emery was distracted. Oh.
Why is it always Henry's fault, bro? Bro's just up here chilling.
Because he threw salads at me
You
yesterday.
probably deserved it.
I'm so ready for Thursday.
And he stole Gary's cookie one time.
Bronsted-Lowry
Why do I have them?
acids and bases are a little more complex. Are they extras?
Yeah.
Just hold on to them for now. I'll get them later. They're a little more complex because we have to do a little more with Bronsted-Lowry. Because Bronsted-Lowry, they look at how protons move. With Arrhenius, we were looking at what can increase the concentration of either hydroxides or hydroniums. Bronsted-Lowry looks at proton movement. Yesterday, we defined a hydrogen ion as a proton. We looked at H+, we saw it had nothing except for a proton. We just called it a proton. In a Bronsted-Lowry, we look at things that can either donate a proton or accept a proton. If something donates something, what does that mean, people? You give it away. You're a donor. When you guys get your driver's license, they're going to ask if you want to become an organ donor.
I said yeah.
You don't have to say what you did or didn't. I don't really care. If you're an acceptor, what does that mean? You're taking, right? It works the same way in chemistry. You see, in certain acids and bases, we can react them and see whether or not they can donate a proton or accept a proton. You're also going to notice the word conjugates on this slide. I guess you people at home haven't seen it yet. This is what it looks like. Copy this down.
Conjugates. Sounds like conjunction.
Conjugate. How many of you guys are in Spanish right now?
Yeah.
You've probably talked about conjugates before.
Oh, have we?
I'll be honest, I haven't taken a single Spanish class since high school. No, I do not remember what a conjugate is. But in a conjugate in chemistry means a pair. A conjugate means an opposite pair. Once we do some examples, you'll see what I mean when I say the word opposite.
Wait, re-say what you just said, because we use the terms conjugates and conjugate pairs to track the movement of protons. That doesn't make any sense in my brain to know what it means. What's the difference? Why do we
Between
use it?
conjugate and conjugate pairs?
Yeah.
Same thing.
Okay, well, what does it mean?
They mean they're a pair of opposites, is what a conjugate means in
So
chemistry.
like a positive and a negative?
Yep. Kind of, sort of. For every left, there's a right. For every up, there's a down. For every forward, there's a backwards.
So like me and Ethan.
Why are you always even with it? Like, he's just over there chilling, minding his own business, and here you are coming out of the woodworks to start some beef.
He's always giving someone attitude.
Frickin' move. Beef farm, brother.
Look at that face.
Like, that's so mean.
No, I'm just saying we're opposites.
Yeah, he's a kind human being, and here you are. I'm
Talking about feces.
gonna make sure you guys do every lab together for the rest of the year.
No.
Actually, you guys only have one lab left.
Really?
Next week. Next week's the last lab.
And then we'll never.
Wait, you're right. That's so
boring. What are we gonna do for the next 2 weeks?
We're gonna do gas laws,
And side
which is gonna take a week, and then it's a review. We do like 2 or 3 weeks of review.
Can you guys believe we're
that
almost?
long left?
Can you guys believe that we're almost done with sophomore year?
I think it's like 5.5 weeks left.
I'm gonna miss you, Ethan.
Lucy's gonna start crying.
I'm ready to graduate, actually.
Me too.
I'm gonna miss you, Ethan.
Still got 2 years, my friend.
3 years.
2 years, I said.
Ethan, we should visit each other over the summer.
I thought y'all were camp again.
All right, do y'all have this stuff written down? Can I start doing
I never
examples?
hear the evil things he says.
Can I start doing examples?
How would Connor feel about this?
There, bro. I have a boyfriend.
All right, here's your first one. Write it down. I don't care, bro. We have HCl reacting with NH3. Bronsted-Lowry, we look at this like a reaction. The first thing I do when I see a Bronsted-Lowry like this, is I need to figure out what's my acid and what's my base. What's my acid here? I have HCl plus NH3. Which one's the acid?
HCl.
How do we know?
Starts with H.
Starts with H.
Claire,
This
don't
is
let me
mine.
tell you a funny story that I can't tell you right now.
Acid.
Okay.
And I told you this is an acid reacting with a base. So if this is my acid, what does that make this guy?
My base.
It's a base. Whoa, but yesterday we said bases. We looked at that whole slide with the 8 strong bases you have to memorize. They all end in hydroxide.
Claire Smith shrimp nachos.
Here's your exception.
Of course.
NH3 is the exception to the base rule. Ammonia is one of the only bases
Exceptions.
that do not have an OH.
Bro, why are there so many exceptions?
Hey, can I tell Claire a funny moment really quick?
I hear somebody speaking, bro. Are you watching a video? Bro.
Claire.
I'm just doing.
Is that driver's ed? What is
No,
that?
it's a lifeguard. I'm a Red Cross lifeguard, but I'm going to go work at somewhere where I have to be an Ellison associate lifeguard, so I have to do all the
Okay,
lifeguard
well,
courses.
watch that later.
I'm
bro.
not watching it.
Claire,
No,
it's-
my full attention's on you. I'm just letting it play in the background.
My video is gonna pick it up. I'm gonna get
I
copyright.
really want you to say.
All right, we have acid reacting with base. What happens in this reaction? What happens in this reaction is the movement of a proton. Hey, on your introduction slide, which one did you say was the proton donor? The acid or the base? Which one's the acid? This guy. So what happens is this hydrogen
It turned into CL.
is going to go on a little vacation and hang out with the base.
Oh, you joking? They go to Hawaii like me.
Speaking of vacation.
So look at my new products. What happens to HCl when he loses his H?
Yo, CL myself. He got stranded.
Hey, CL, is that a Brinkelhoff?
Yeah.
Heck yeah, it is.
So we have to do the two. Add a 2, add a 2, add a 2.
Diatomic molecule.
Wait, ions break. Wait.
But look what happens. You also, your ions break Brinkelhoff.
Yeah.
We said hydrogens were pluses, right?
Yeah.
So when this chlorine loses a plus, what does that make him?
A negative.
A minus.
Chemistry's clocking.
When NH3, he gains a proton.
This is schizophrenic.
When NH3 gains his proton, what is he going to become?
No, he's literally delusional.
NH4, but he gained a positive guy, so what's his charge going to be?
Plus.
Plus.
And then you have to cross it.
Nope.
You just count that.
Yep.
That's schizophrenic. And that goes against everything I've ever learned.
Yeah, this is
in
literally
class.
schizo. Like you sound insane right now. Can I put you in a straitjacket?
No. NH4 plus is going to be another exception, and we're going to talk about why. Hey, let's start with Cl minus.
Where's the padded room, bro?
We need to talk about conjugates. You see, a conjugate is an opposite. And there's always two pairs of conjugates for every Bronsted-Lowry problem. I want you to look at Cl minus. Looking at your reactants, which one looks the most like the Cl minus?
The HCl.
The HCl, right? They look basically twinsies. The only difference is that this guy has a hydrogen. It was an acid. But when it loses his hydrogen, what do you think he becomes?
A base.
He becomes a base.
See, that's schizophrenic.
Yeah, you're insane, dude. I'm not gonna lie.
But it's not just a base. We call it the conjugate base.
Your marker's dying.
Okay, can I tell you a story real quick? What does this remind you of in 7th grade in Miss Siemens' class?
I did not. I just had.
Turn around. Yeah, turn around. What does this remind you of? 7th
Oh my
grade
gosh.
Miss Siemens' class? That's all I think about.
NH4. What does he look the most like? What does NH4 look the most similar to? Like NH3.
Yeah, I remember that.
You were not there.
But I remember you telling me.
If this guy was a base, he gained a proton. He's the proton acceptor. What's his conjugate going to be? He's the conjugate acid.
Do you have to like label these and test this?
Yes.
So basically, they just switch. Is this how it's always gonna be? They just switch.
Kind of, sort of.
Oh, there's exceptions, aren't there?
Hey, we just called this guy an acid. But it doesn't start with hydrogen.
It's an exception.
Here's your other exception.
No, because it switches. So wait, the H is the.
Yes, but I remember those with
The NH4 plus is the conjugate acid.
I had to back in the Hus, dude. I did not end up back in the Hus, by the way.
That is 66% of your problem.
66.
You don't hate was also in that class.
Look at this chart I just gave you a little bit ago.
Do we have to draw that on the side?
Nope, you have it.
No, the side that is favored is the side that has the weakest.
If you want. Because
She
it'll help you
hated
remember.
us.
She hated us so much. And I don't know, remember she always banned me from playing Monkey March. She said it was racist.
It is.
Yeah.
I don't know what it is. I'm just kidding.
It's a game about monkeys running a grocery store.
Yeah.
It was really fun.
Looking at your reaction, the last thing that you guys have to do, and this is an honor skill that I made because why not make it a little harder, is you need to use this chart to be able to tell if a reaction goes forward or backwards. You see, in nature, when these two things are next to each other, they can react to form this. But at the same time, if these two things are right next to each other, they can also react to form these. We call that either going forward or backwards. Now, for you guys, there's a very easy way to predict which way this reaction goes. And it's by looking at this chart. Looking at your chart, the left side talks all about the acids. The right side, all about the bases. Cool. If we look, they almost go directly across from an acid to the conjugate base. The base to the conjugate acid, vice versa. Okay, so that's a very easy way if you're like, I don't know what the conjugate acid is.
Yo, this is going straight through my ears. I'm not gonna lie.
So write it down. The easy way to tell if a reaction is going to go forward or backwards is by doing this. We got to look for which side has the weaker acid. The side that has the weakest acid will always be favored. So in our case, if we look at our reaction, we had HCl as one of our acids, and NH4 plus was our conjugate acid.
HCl's like at the top.
Looking at my chart now, I see HCl way up here, and I see NH4 plus way down here.
Wait, they're both.
And the strength goes up like this. So HCl is up here, NH4 plus down here. Which one's stronger?
The HCl.
So which one's weaker? The NH4 plus. So which direction is my reaction going to go? Forwards, which is this way, or backwards, which is that way?
Backwards.
We favor the side that has the weakest acid.
NH4. You're going forward.
We're going to go forwards. So this would be a forward reaction.
What?
The one we just did is a forward.
Yep.
Can we get homework now?
Nope.
So you can't.
Yep.
Whoa.
Does the pink one matter, or is it just for the? Mine's pink. Does this one matter, or is it just for this one?
Huh?
The forward reaction and the backward reaction. Is it just for the one on the right?
This whole thing is a forward reaction.
Yes, but it doesn't matter for the left one.
I mean, that goes for the whole reaction.
No, like.
It's fine.
I don't think I know.
Yes. No. Yes.
I don't think I
You guys
know.
don't understand what I'm asking.
I do not.
It's whatever.
It's alright.
How do you choose the one?
What?
How do you pick which one to do, like base or acid?
It's always the acid. You're always just going to do the acid. All right, here's number 2. Br minus plus H2SO4.
This is the next one.
Yep. What's my acid? H2SO4. Does anybody know what acid that is? Sulfuric acid. If that's my acid, what's my base? My proton acceptor. The bromide.
So you have to take one of the acid, you have to take the hydrogen out of the BR.
We're going to take one of the hydrogens from my acid, send him on a vacay to bromide.
So it's HBr plus HSO4.
So we'll have HBr. What's the charge of HBr going to be?
It's going to be plus negative.
It was negative. We had Br minus. It gained a positive.
We get a plus.
So it's neutral.
What?
Oh. Yeah, this is dumb. I'm putting you in the straight jacket, bro.
Now we have H2SO4. It's a neutral, but it lost one positive. So now what's he going to be?
Minus.
Minus.
And then you have to do fun little things like figure out which one's the conjugate base and
So here's my base. What looks the most similar to my base here?
HBr.
The HBr.
Oh no, you're squished, bro. Why do you smile at this?
If HBr is the most similar, if this was my base, what's he going to be?
Right behind you. It's right behind you.
The conjugate acid.
Way back there. Just throw it back.
Or just set it on your table.
Hey, which one looks the most similar to sulfuric acid?
HSO4.
HSO4 minus.
So that one is the conjugate base.
Very good.
This is clocking now.
Do you see the video I sent you where it's like now at 5 o'clock on the That one was so funny.
Now I need to figure out which one or which direction the reaction is going to go. Looking at your paper, what direction is the reaction going to go?
That's a good question.
It's gonna go forward because HSO4 is like at the top.
You're right. H2SO4 way up here at the top, whereas HBr a couple spots below it. It's going to go towards the weakest acid. So therefore, this is a forward
This
React.
actually makes sense.
Yeah, I'm not getting the forward part, but I get everything else.
That's one of the easiest
I get this part.
Hey, I'm sorry, it's just not clocking.
Okay, I got one more. HF plus water.
Good, because I'm almost out of space.
Actually, we're gonna do 2 more, I think.
Bro, we have like 3 seconds left. Give us our homework and let us leave, bro.
That's just not true.
What time do we get out?
We get out.
Like
we have
5
minutes,
minutes.
Yeah, and I don't have time to pack up my bags.
You'll be alright.
I'm a really slow packer, but it's okay.
Bless it, bro.
Which of the following correct statement is about your second duties?
He's not gonna, he hates us.
Second duties.
Mr. Mead hates me tonight.
What?
Can we come down and study hall so we can work on our homework?
Sure.
He loves us.
Mr. Mead,
What?
I'm gonna also come down, but I don't have study hall till. Never mind, I can't.
Alright,
I have to finish this.
hey, speed run this.
Bro, what?
We have HF plus H2O first. Which one's my acid?
HF.
HF.
Wait, how do you figure out if they're acids? Because water isn't an acid.
Water can be both, so you can make that your base, right?
Water can be both, so that guy
So you get to pick.
can be my base.
So you can pick which one is your acid or
Look, always look at the other guy. If the other guy, this guy can't be anything except an acid, right? HF can't be anything except an acid. Do you agree?
Why not?
Yes, I'm
Because
like
it
that.
starts with an H.
Oh, because he starts with an H.
But
Yeah.
water can be both,
Oh.
so he can start as my base.
Dude, that's
Predict your products. The H is going to go on a vacation from the acid to the base, so my acid will become F minus, and the base of water is going to become H3O plus.
Yo, H3O.
Hey, F minus, is that the conjugate base or the conjugate acid?
conjugate acid. Wait, base, I mean.
Conjugate base.
I'm at base.
H3O plus, is that going to be the conjugate acid or the conjugate base?
Conjugate acid.
Good. Which direction is this reaction going to go? Look at your sheet.
Probably backward.
I'm thinking it's backward because we haven't done one yet, so I'm gonna take a wild guess.
Look, here's HF way down here. Here's H3O plus up here.
Yo.
So which one's smaller? Which one's lower? We go towards whichever one's lower. So we're gonna go towards this guy or that guy?
This guy.
We want to go backwards.
Yo, I'm a fucking genius. I don't know my direction.
That's not wrong.
All right, the last one.
What?
Hey, which one's my base? ClO4 minus or water?
H2O. H2O.
ClO4 minus is my base, which makes water my.
Acid.
Oh my gosh! Look, it can be both. Up here it was a base. Down here is an acid.
Dude, that's crazy.
I'm locked into life.
When you predict your products, you'll get HClO4 plus OH minus. OH minus is your base. HClO4 is your acid. I know, it's because I'm just writing these.
I don't see, wait, where's the H2O at? ClO4.
Which direction is it going to go?
I can't find water. Oh, it's right here.
Water, it's in the yellow. So here's water. And then we have HClO4, which is way up there.
So it goes backwards.
This is another one that's going to go backwards.
Awesome. My homework yet?
You're going to do 4 problems from the front, 4 problems from the back by Thursday. Or no, by Friday.
Yo, that's tough.